Welcome to our lecture. The lecture of today is of capacitor lab, and we will understand the basics of capacitors and their behaviors in lab. So the topic that we are going to study today are capacitor, and what we are doing, we are understanding the basics of capacitor by using a PHET feed simulation, and that is the basic lab of capacitor. Before starting with the topic, let us see the objectives of our lecture. What is the objectives of our lecture? Lecture objectives number one: explain the relationship between charge and voltage in a simple capacitor. If we have a capacitor, a simple capacitor, so on that simple capacitor, what is the behavior of charge and voltage? The second objective that we want to achieve today: explain the relationship between capacitance and area, comma, separation between the plates of a parallel plate capacitor. If we are given a parallel plate capacitor, it has some capacitance, and we will find the relationship between the area, separation between the plates of that parallel plate capacitor, and what will capacitance will have effect on increasing or decreasing it. So that is our lesson objectives of today. Now, before proceeding on to the lab, let me remind you of some basic concepts. What is a capacitor? Just see that if the water supply is not continuously coming to our home, so what we have to do? We have to build a tank in our building, in our Bangalore, to store the water, and it contains some potential energy, it contains some energy in the tank. So in the similar manner, we need electrical energy. And what does capacitor do? Capacitor stores electrical energy. We can often say it capacitor is a device that stores charge. It stores charge. And what does this charge have? This charge possesses some energy, and we can also write as it stores not charge but electrical energy, because when charge travels from one place to another place, it possesses some energy, and at that point when it comes to from A, it comes to B. So at point B, it is coming from A to B, it has some energy, and that energy, if it is coming on the plates of a capacitor, that energy will be stored in that capacitor. So capacitor has many different variations, many different types, but what type of capacitor we will discuss in this lab? We will discuss the simplest capacitor, that is parallel plate capacitor. It contains two metal plates that are separated by some distance d from each other. So I am highlighting it with the help of wet marker, so you will be easy to visualize. The distance between the plates is d, and it can have some air or some dielectric between them. So this is a simplest form of capacitor, that is parallel plate capacitor. So that is some basic knowledge of capacitor that you need to know before proceeding on to the lecture. Now let's move on to the main part of the lecture. So we will be using a simulation, and that simulation is of feed simulation. How can you use it? Now look at it. Capacitor virtual lab, charging capacitor, and what is the method? The link is given in this sheet, that is open the simulation. You have to copy and paste this thing onto your browser, and when you copy and paste it onto your browser, so a simulation will open, and that simulation will be of capacitor lab basics. I have already opened this simulation onto my computer, onto my browser, and you can see that it contains a simplest parallel plate capacitor. it contains a battery, and it contains all the checks that is mentioned in this simulation. You can see, connect the capacitor across the battery. Capacitor is connected across the battery. You can see in this diagram that capacitor is connected across the battery, but that battery is not yet open or on, you can say it. Now let's move on to it. You have to check all of these things, all the parameters, plate charges, bar graph, electric field and current direction must be selected as shown below. So in my simulation, I have checked all of them: plate charges, bar graphs, electric field and current direction. Now let's start our venture. What we are going to do: connect the voltmeter across the capacitor and record your observations below. So you are saying that I have connected the voltmeter across the plates of a parallel plate capacitor. Now I have a table here, and what I will do, by using simulation, I will fill this table, and that is the basic part of our lab. Now let's start. Number one thing, increase the battery voltage to plus 1.5 volt. So what I am doing here, increasing the voltage to 1.5 volt. I have done this. Now let's move on to the there. What happens to the charge on plate? So you are seeing that plates are charged. Plates are charged. When I have increased the voltage to 1.5 volt, so what happens? Plates are charged. So what I will write? They are charged. They are charged. So plates are charged here. Charge on the upper plate. So as charge on the upper plate is positive, and the next column is charge on the lower plate. Charge on the lower plate is negative. So we can write it: charge on the upper plate is positive and charge on the lower plate is negative. Let me. Now what I have to do? Direction of the electric field. So in this simulation, you are seeing, by using black arrows, that electric field always goes from positively charged plate to negatively charged plate. So it is going from positive to negative. So I can write it here: from positive to negative. Now that is important, very important observation that we are going to do, and that will match our observation lesson observation number 1, lesson objective number 1. Now let's move on. Potential difference is 1.5 volt. So I will write it here: 1.5 volt and what is the charge? Charge is 0.30 picofarad. So I will write it here: 0.30 picofarad. I have write it here. Observe one more thing. As I have increases the voltage, let's take it to 0 volt. Now I will increase the voltage. As I am increasing the voltage, charge on the parallel plates are also increases. Charge on the parallel plates are also increasing. So you are saying it, I will writing it here: as I am increasing Q, as Q is increasing, so potential difference V is also increasing, and we are increasing this potential difference with the help of battery. Now let's move on to the simulation. I am increasing, charge is building up, and when I am decreasing, charge is removing. and when I have changed the direction of it, when I have connected to the positive terminal to the another plate and negative terminal to the another plate, so charge is already building, but it is building in the opposite direction. You see. So what does it tells us about the charge and voltage relationship in a simple capacitor? It tells us that the relationship between charge and voltage is direct. If you increase the potential difference, then charge on a simple capacitor, parallel plate capacitor, will also increase. So what will you identify? How have you identified? You have seen this by using simulation. If I decrease the battery to the 1.5 volt, the capacitor is charged. You are saying this. Charge on the upper plate is now negative, on the lower plate is positive. Direction is same from positive to negative. When we are talking about, let's say I am doing this to minus 1.5 volt, I have taken it to the minus 1.5 volt, just a change of direction. Capacitance is still 0.30 picofarad. There is no effect on it. But what is the effect on the charge? The charge is increasing continuously when I am increasing the voltage. When I am increasing in the opposite direction, so that is happening to you, that the direction has changed but the capacitor is charged. Now let's come to the observation number 3. Keep the battery voltage at 1.5 volt and increase the plate area. Now let's see what is happening. I will be keeping the voltage at 1.5 volt. That's what I have done. And I will increase, what I will increase? I will increase the plate area. So the things will remain same. It will charge, and charge on the upper plate is positive, on the lower plate is negative. Field is from positive to negative. Potential difference is 1.5 volt. But now I will increase the area. What will happen if I increase the area? Now let's see on the simulation. That is the plate area. I am increasing it, and you are seeing this. On 200 millimeter square, it is 0.30 picofarad. When I have increased it to 210, the capacitor has become 0.31. When I have increased it to 230, it becomes 0.34. And when I have increased it 240, the capacitor has become 0.35, and it goes on. As we increasing the area, the capacitance of the parallel plate capacitor is increases. That is 0.43 picofarad. I can write it in our observation, 0.43 picofarad. So what is the outcome now? That the capacitance of the parallel plate capacitor is directly proportional to the area of the plates. As we increase the capacitance, then the area of the plates will also increase. On the next thing, that I have to keep the voltage, things will remain same, but what will happen when I will decrease it? You are seeing it by your own eyes. I am decreasing it, I will be decreasing it, and at 170 millimeter square it becomes 0.25 picofarad. Means if I am decreasing the area, the capacitance is also decreasing. When I am increasing it, it is also increasing. So I can write it here 0.25 picofarad. Now I will do the observation, that is the next observation by your own, and the last observation will be done by you as your homework. So it is 1.5 volt, it is from positive to negative. Direction of electric field is from positive to negative. The voltage is still at 1.5 volt. Now what I have to do? Decrease the separation. I will decrease the separation between the plates by using our simulation. So now let's do it. As I am decreasing the separation, the capacitance is increasing. Separation is decreasing, but capacitance is increasing. Now let's see this. If I am increasing the separation, so capacitance is decreasing. One variable is increasing and one variable is decreasing. Now let's see. I have decreasing the separation and the capacitance is increasing. And by I am increasing the separation, the capacitance is decreasing. So what is the relationship between those two variables? The relationship between those two variables, that is capacitance and the separation between the plates, is inverse. What is it? Is inverse. So last observation is by your own self. What is the capacitance coming at 4.4 millimeter and 170 millimeter square, that is 0.34 picofarad. I will be writing it here, 0.34 picofarad. So now let's move on to the objectives of the lectures. Let me go to the original slides. So now what is your homework? What you will do? You will be able to explain the relationship between charge and voltage in a simple capacitor on a simple worksheet that is provided by you to me. And you will be able to explain the relationship between capacitance, area, separation between the plates of a parallel plate capacitor that we have discussed in this lecture by using the PHET simulation and by using this check. Thank you so much.